Hello students, how are you all? I hope all of you are doing great. So welcome all of you at AriserTalent, and today we are going to deal about the NCERT questions which is related to your chapter, that is matter around us pure. In our last lecture we have a discussion about some of the separation techniques and we have discussed about the physical and chemical changes, and this chapter was over there. Now let's deal with NCERT exercise, which is the exercise part of your chapter. So let's proceed with the first question. This is our first question. Which separation techniques will you apply for the separation of the following? So you have to actually identify that which separation techniques is used for separating these components. Sodium chloride from its solution in water. If you want to separate sodium chloride from the water, what you have to do? You have to do the evaporation. Evaporation is a process that you can apply for separating sodium chloride from the water. Ammonium chloride from a mixture containing sodium chloride and ammonium chloride. If a mixture of sodium chloride and ammonium chloride is given, we know that ammonium chloride has a property to sublime easily. So you will adopt the method that will be known as sublimation. Clear? Now, small pieces of metal in the engine oil of a car. If in the engine oil small particles have been fallen, you can separate them easily with the process known as filtration. So filtration is a process for separating something here from the oil particles. Next, different pigments from the extract of a flower petals. Flower petals are of different colors, and if you want to obtain the different colors from them, you will adopt only one single method, that is known as chromatography. So the answer is chromatography. Next one, butter from curd. If you want to separate the butter from the curd, this is the same technique as separating the cream from the milk, that is actually known as centrifugation. So what we will use? We will use a process that is known as centrifugation. So centrifugation is actually a process for separating butter from curd. Now the next process is oil from water. If you want to separate oil from water, what you have to do? You have to perform the sedimentation. The sedimentation is a process in which the particle is going, the heavier particles will settle at the bottom and the lighter particles will float on the surface. So for separating the oil from water, you know that both are the particles having the different densities. So which method we will adopt? We will use the separating funnel for separating oil from water. So it will be separating funnel. Clear? Now the next questions are tea leaves from tea. If you want to separate the tea leaves from tea, you will basically do a single process that is known as filtration. Tea leaves can be separated from the tea by the method of filtration. Iron pins from sand. As iron is having a property to attract the magnet, is having a property to attract the piece of iron, so we will use the magnet for separating iron pins from sand. Next one is wheat grains from the husk. This is a very common activity you have observed in your homes. When your mother is just clearing the husk from the wheat, she will either do winnowing, or you can say you can done the sedimentation also, because the particles will settle down. So wheat from the husk is separated by the method which is simply known as winnowing. Winnowing is a process in which the wheat is going to be separated from the husk. Now, fine mud particles suspended in water. So, fine mud particles if suspended in water, you will perform the process that is known as decantation, so that the clear water you will get at the top, and the particles of mud will be settled at the bottom of the container. So this process is actually known as decantation. It is magnetic separation. So here are few of the processes that we have seen in the separation techniques that is used to separate different component here. So this is a very important question, because 1 mark question can be arise from such part that how you will separate one thing from the another thing. Clear? So this is all about our first question. Now let's proceed to the next question. This is our step number 2. Write the steps you would use for making tea. Use the words solution, solvent, solute, dissolve, soluble, insoluble, filtrate and residue. So it is a very simple and the common question. You have to write the steps for making tea. Do you know the steps for making tea? The steps for making tea are very simple, but what you have to use these words for making your sentences. So let's try here. Step number 1. If you want to prepare tea, what you have to do? You have to just take a water in a container and boil that water. The first step is take the water in a container and boil it. Okay. Now in the step number 2, what you will do, you will just add the sugar in that water, and you can see that if the water has been boiled, the sugar is going to dissolve in the water. Clear? So this is step number 2. Step number 2 is add sugar in water and it gets dissolved in it. If you add the sugar in water, the sugar is going to dissolve in that boiled water. Now, in the third step, add some tea leaves in that sugar solution. So, in the step number 3, what we will do? We will add tea leaves here. You have to add tea leaves in that solution. Now the tea leaves is not going to dissolve in that solution, as the tea leaves that we are using for making the tea, you have to filter that tea leaves for obtaining the tea. Clear? Now in step number 4, add some milk. You have to add some milk in the container. As you are going to add milk in the container, the whole content is going to boil and you will get the tea there. Clear? So, after boiling, whole solution, what you will get? You will get your tea prepared, and the tea leaves are residue here, and the tea which is filtered is known as filtrate. Clear? So this is how you can prepare the tea. So you have to use these words and you have to make the sentence of your own. You can make your own sentences also. It is not just like that you have to copy this from here. So this is the terms we are using: filtrate. We have used the term residue. Residue is the tea leaves there. Then we have used the term solution. We have used the term dissolve. So by using these terms, you can form your own sentence also. As one sentence you can make here, when you are adding the tea leaves in the solution, it is insoluble. Tea leaves is not going to be soluble in that water that you have boiled. So we can use one more term, that is insoluble here. So by using these terms, we can make the sentence of their own. Clear? So this is all about the whole process for making tea. Now, let's move to the question number 3 here. Pragya tested the solubility of the 3 different substances at different temperature and collected the data given below. So what she has done, she has measured the solubility of 3 different substances at 3 different temperatures, and the table is showing here is the gram of a substance dissolved in 100 gram of the water to form a saturated solution. So the whole quantity is dissolved in 100 gram of the water. So the table given here is, you have given some substance at different temperature and you have given a different solubilities here. Now what you have to identify, the first part here is, the mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 gram of water at 313 Kelvin. So now let's see in the table that at the temperature of 313 Kelvin, the potassium nitrate you are getting at the 100 gram of the water is approximately 62. You can see that the potassium nitrate is having a solubility of 62. So I can write here for the first part, in 100 gram of water at 313 Kelvin, solubility is 62 gram. So you can see that in the 100 gram of the water at a particular temperature of 313 Kelvin, you are getting the solubility that is 62. Now what you have to do, we have to identify the solubility in the 50 gram of water. So similarly, in 50 gram of water at 313 Kelvin, what will be the solubility here? The solubility is going to be calculated by using the unitary method, in which this thing has to be substituted in numerator, 100 in the denominator, and you can write 50 here. Clear? This is the unitary method we have applied here. Now what will happen in this case? 0 will be cancelled by 0, 5 1 are 5, 5 2 are 10, 2 and 62 will be cancelled, and what you will get here? You will get here the 31 gram. So in 50 gram of the water at 313 Kelvin, you will get the KNO3, which is 31 gram, just half of this. So the solution for the first part is 31 gram. So the answer for first part will be 31 gram. Clear? Now let's move forward to the part number B. Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? Okay, so let's see at 353 Kelvin what she is doing. She is having a solution of potassium chloride in water, and what would she observe as the solution cools? So let's see the table again. This is the table. Now what she is using potassium chloride at a temperature of 313 Kelvin. So potassium chloride at a temperature of about 313 Kelvin is 40. 40 is the quantity given for the 100 gram of water. So what she has done, if she is using and she is just doing that the solution is kept at a room temperature, then she will observe that the solution cools. And why it is happening so? Because the temperature is lowered, so the solution will be cool very quickly. So what will happen when you cool the solution? You will get the crystals of potassium chloride here. So on cooling the solution, she will get the crystals of potassium chloride. So on cooling, she will get the crystals of potassium chloride. Now, the third part is you have to find the solubility of the each salt at 293 Kelvin. So just look at the table and observe the different components at 293 Kelvin, and you have to identify which salt has the highest solubility at this particular temperature. So what you have to do? We have to move to the table again. So let's move to the table again. This is the table, and you have to observe the things at a temperature of about 293 Kelvin. So at 293 Kelvin, this is the temperature at 293 Kelvin. Now you can see that potassium nitrate is 32 gram, sodium chloride is 36 gram, potassium chloride is 35 gram, and the ammonium chloride is 37 gram. So I can found here that the solubility is highest for ammonium chloride here. So just let's draw the table here. Here we will write the substance dissolved, and here you have to write the solubility in grams at 293 Kelvin. Clear? So potassium nitrate is having a solubility of 32 gram. So the first component is potassium nitrate, and potassium nitrate is having a solubility of 32 gram. Next is sodium chloride. If I am going to talk about sodium chloride, the sodium chloride is having a solubility 36 gram. If we are talking about potassium chloride, its solubility you can find here is 35 gram. So potassium chloride is 35 gram. Next one is ammonium chloride, which is having a solubility of 37 gram. So ammonium chloride is 37 gram. So what you can find here, we have seen that the solubility of the ammonium chloride is highest at a temperature of 293 Kelvin. So you can say that ammonium chloride has the highest solubility. So the answer here will be ammonium chloride. Ammonium chloride, and its solubility is 37 gram. Clear? So this is the answer for this part. So this is our question number 3rd. Now let's move to question number 4th. What is the effect of change of temperature on the solubility of the salt? As you keep increasing temperature, the solubility of a substance is going to be increased. So the effect of temperature is that, D part I am solving here. As temperature is increased, the solubility of a substance is going to be increased. Clear? As the temperature is increased, the solubility of a substance is going to increase. So this will be our last part. So again, this is a very conceptual question from our NCERT. So just focus on these questions. Now, let's move to the next question, that is our question number 4. Explain the following by giving some examples. These definitions are very simple definitions that we have discussed in our chapter, but we are just doing a revision again. So let's see the first term, saturated solution. Saturated solution is a solution in which for a particular temperature no more solute can be added. So this type of the solution will be known as the saturated one. Clear? So first one is saturated solution. So saturated solution is solution in which no more solute can be added. An example, you can consider any of the example here. Suppose in 100 gram of water, 30 gram of sugar is added. If you add 30 gram of the sugar in 100 gram of the water, you can see that the solution is going to become saturated. Now, the next question is about the pure substance. So now the next question is the pure substance. Pure substance is actually a substance which is made up of same kind of particles. If I am talking about gold and silver, it only consists of same kind of the particle. So pure substance, it is a substance which consists of same kind of particles. If a substance contains same kind of particles, it is said to be the pure substance, and the example you have is gold and silver. Clear? Now, the third definition we have is about the colloid. Now, what is colloid? Colloid are the particles in which the particle size is bigger as compared to the solution one. Okay, so colloids are the large particle size which is having the tendency that it is going to randomly move in a solution. If I am talking about the milk, milk is a colloidal solution. Clear? So colloid will be the particles in which the particle size is greater than the size of its own. Suspension. Suspension are also the particles which are keep suspending in a solution. Suppose if you are adding the mud in a water, what will happen? This mud is going to be suspended in the water. So such kind of the solution will be known as the suspension one. Clear? So these are the definitions which we have discussed previously in our chapter 2. So we are proceeding to the next question we have, and the next question in this sequence is question number 5. Classify the following as homogeneous and heterogeneous mixture. So the fifth question is, you have to identify the homogeneous and heterogeneous mixture among the following. So we are just separating the homogeneous mixtures and heterogeneous mixtures. So homogeneous mixtures are those in which there is a similar kind of the particles. It means the mixture is uniform throughout. But in heterogeneous mixture, you have the different constituent of the particles. So if I am talking about the soda water is actually the homogeneous mixture we have. So soda water is homogeneous. Wood is actually a substance which consists of different kind of the particles you have. So wood is not a uniform composition. So wood is our heterogeneous mixture. Air and soil are the heterogeneous mixture because they consist of different kind of the particles. So air and soil are heterogeneous mixture. Vinegar and filtered tea. In the vinegar you will see that acetic acid will consist of the same kind of the particles, and in the tea you will, after tea is filtered, you will get the same composition here. So vinegar and filtered tea are homogeneous. So this is a very simple question from your NCERT. You have to just separate the homogeneous and heterogeneous mixture. Now let's move to the next question in this sequence. Now let's proceed to the next question, which is our question number 6, and let's see what the question number 6 is saying. How would you confirm that the colorless liquid given to you is a pure water? Suppose you are given a water, then by its boiling melting point you can identify that the water is a pure water, because any pure thing has a fixed value of boiling point and the melting point. If you keep boiling this water and if it is boiling at 100 degrees Celsius, you can say that the water is a pure water. So the answer will be pure water has fixed boiling point. That is 100 degrees Celsius. If you keep boiling this water, if we boil water and it boils at 100 degrees Celsius, we can say that it is a pure water. So pure water can be easily identified by boiling it. If it boils at a temperature of 100 degrees Celsius, we can say that the water is actually the pure one. Clear? So this is the solution here. You can copy this from here. Let's move to the question number 7 here. Which of the following material fall in the category of the pure substance? Now the pure substance is the one which is made up of the same kind of the particles. So if I am talking about the ice is actually a pure substance because it consists of the same water particles. So I can say the category in the pure substance are So we have to identify the following compounds that is falling in the category of the pure substance. So pure substance are actually those substance which is actually made up of the same kind of the particles. So if I am talking about ice is our pure substance. Clear? So first one is ice. So ice is actually a pure substance. Second is milk. Milk is not a pure substance. It is a colloidal solution in which different constituent particles are present. So you cannot say that milk is a same pure substance. If I am talking about iron, iron is again a pure not a pure substance you have, because it also consists of the mixture of some metals too. Okay. If I am talking about hydrochloric acid, it is a pure substance because it consists of hydrogen and chlorine gas. So uniform solution will be obtained throughout. So after ice, the second one is hydrochloric acid. It is a pure substance. Third one is calcium oxide. Calcium oxide is again a pure substance because it consists of the same kind of the particles. So calcium oxide is a pure substance. If we are talking about mercury, mercury is again a pure substance because it consists of only single type of the element. So the fourth one is mercury, and mercury is again a pure substance. Next one is brick. Brick is actually not a pure substance, as the brick may consist of different constituent of particles. Wood. Wood is again not a pure substance because it consists of different kind of the particles here. Air again is a heterogeneous mixture in which the different kind of particles are dissolved, or dust particles are also present in the air. So this is a category which is showing that these are actually the pure substance. Clear? So this is a category of the pure substance which is made up of only same kind of the atom. Here there is one more element like iron. Iron is only made up of the Fe atoms, so we can also say that iron is also a pure substance. Clear? So this is a category which is showing that how many pure substances are there in the given list. Now let's move forward to the question number 8. And the question number 8 of the sequence is, identify the solution among the following mixture. So firstly, if I am talking about the soil, soil is not a solution. Soil is actually not a solution. If we are talking about seawater, yes, seawater is a solution because it contains a variety of the salt dissolved in it. Okay, so seawater is a solution, it is true. Air is again a solution because apart from all the gases, dust particles and water vapor are also present. So we can say that air is a solution. Next one is coal. Coal is not any type of the solution here. If we are talking about soda water is again a solution because gases are dissolved in a particular type of the water. So in the given list, you can see that sea water, air and soda water are actually the solutions. So this is, you can see, a very simple questions are from your NCERT. Clear? Now let's move forward to the question number 9. Which of the following will show you the Tyndall effect? Now in our chapter, we have a discussion about the Tyndall effect, and Tyndall effect is basically shown by the particles which are actually colloids. Clear? So salt solution, milk, copper sulfate and star solution. So among all these solutions, there are two colloidal solutions, that is milk and starch, and they are definitely going to show you a Tyndall effect. Whenever you are going to pass a light through them, you will see that the particles will be separated as we have discussed in the Tyndall effect. Clear? So milk and starch solution is going to show you the Tyndall effect. So I can found here my option B and D are correct. Okay. So this is our question number 9 we are having. Now let's move forward to the question number 10. Classify the following into element, compounds and mixtures. So you are provided with a list of various components and you have to separate them as element, compound or mixture. So we are just drawing the table here. One is for elements, second one is for compounds and third one is for mixtures. Now the first part is sodium. Sodium is actually a metal and metal is a element. So I can write sodium in the category of element. Next, soil. Soil is a compound or mixture. Soil is actually a mixture because it consists of different particles. So soil is a mixture. Sugar solution. Sugar solution is again, you have sugar dissolved in water, so you will get a sugar syrup and it is actually a compound. So sugar solution is a compound. Silver. Silver is a metal, so it is again element. Calcium carbonate. Calcium and carbon and oxygen. So it is a mixture of 3 type of the elements, so it is a compound. So calcium carbonate is a compound. Tin. Tin is actually an alloy. So tin is actually a metal. So metal is counted in the category of element. Silicon. Silicon is again a metalloid you have. So silicon is counted in the category of element. Coal. Coal is actually, you have a mixture of various kind of the particle. So you can say that coal is a mixture. Next one is air. Air is again, that is mixture. Clear? So here is a list of the particles which are element, compound and mixture, and one simple rule to identify them is that if it is made up of only one kind of particle, that is element. If it is a mixture of more than one kind of particle, it will be compound, and if it is a mixture of different kind of the particle showing different behavior is known as the mixture. Clear? So compound will consist of two particles, mixture is consist of lot of particles, and element will have only a single type of the atom present in them. Clear? So you can identify the list by following this simple rule. Now let's move forward to the last question of your NCERT, that is question number 11. So let's see what the question number 11 is saying. Which of the following are chemical changes? So chemical changes are those changes in which there is change in the chemical properties of a substance, or you can say that the chemical behavior, the molecular behavior of a substance is going to be changed. So first one is the growth of plant. Growth of plant is a chemical change because whenever you plant any tree or you can plant any plant, you can see that you will insert a seed in the soil and it is going to give you the flowers, it will going to give you the leaves. It means the new substance or the new product is obtained here. So I can say that the growth of a plant is a chemical change. Clear? Rusting of iron. Rusting of iron is a chemical phenomena in which oxygen and water is going to react with iron and a brown colored freaky layer is deposited on the surface of the metal. So again it is a chemical change. Mixing of iron fillings and sand. So simply you are just mixing iron fillings and sand and no reaction is going to take place there. So it is not a chemical change. Clear? Cooking of food. Cooking of food is actually a chemical change because when you put raw vegetables in a cooker or any other container, you will get the food in the cooked form. So cooking of food is again a chemical change. Digestion of food. The digestion of the food in our body is a process that is completely chemical because few of the acids, few enzymes and all the metabolic activities that is occurring in our body is a kind of chemical change. So it is a chemical change. Freezing of water. Freezing of water is not chemical change because when you freeze the water, it is simply converted into ice. Only the physical state of a substance is going to change. So it cannot be identified in the category of the chemical change. Clear? Burning of candle. The burning of candle is a type of chemical change. Why it is so? Because when you burn the candle, the molten wax present there is going to melt and it is going to produce the carbon particles at the wick. Clear? So it is a chemical change. So these are few of the questions which are related to our NCERT, and this lecture is all over for today. We will deal with competitive questions in our next lecture. Thank you so much and have a wonderful day.